So, well, hi, my name's Andrew Tratz, and I'm the sole member of the Tricksy Hobbitses team. And it was a pleasure competing with all of you, and thanks to the program managers for running the competition. Let me just jump forward. I'll skip over my background. I'm a computer science major. I've done a lot of kind of business roles for the past decade or so, but kind of coming back to AI now. In terms of the solution, I use two different pieces of this. I think many of the competitors who got gold or prizes did something similar, where they combined the alphabetic binary search and an LLM based solution. In my case, I use an online only LLM, so I didn't rely on any pre-processing of any of the questions beforehand. So everything is done on the fly. But to make that work, there was a bit of kind of control required to make sure that it wasn't just kind of going off the rails. So I'll go through some of the details on how that worked. In terms of just, I did a performance assessment kind of after the competition started running. I spent a lot of time looking at metrics. Thanks to Loma for doing your work on getting everything out of Kaggle. The alpha strategy, my particular bot had an 89% find rate on the keywords, so it was able to find most of the keywords that it encountered, and it was reasonably fast, although not the fastest in terms of how quickly it could get to the right answer. My LLM-based strategy did fairly well in the competition as well. It had a 11-12% win rate in the LLM only, kind of the standard game modes that it was playing. And it did fairly well according to some custom metrics. It also was doing fairly well on the public leaderboard at one point when I pulled it off to kind of work on iterating some new strategies, and combined ended up number 2, although that could have been all over the board. It was pretty close.
Sorry.
Yeah.
Just quickly checking, are you going into the next slides or?
Yeah, I am. Is that not showing up?
Yeah, maybe you might want to just change slides from the main window.
Okay, can you see that now?
Alpha strategy?
Yeah, alpha strategy, LLM strategy.
Yes, I think
Okay.
we're on.
All right, let me go there then. You can still see it.
Yep.
Okay, moving on here. So just kind of a flow chart for how the program works. I asked the is it agent alpha question and to determine which strategy to proceed with. For the alpha, my strategy was, since there were a lot of single word keywords, and I anticipated that would be likely in the final private keyword list too, I focused on getting the first word of the phrase first. And if I've narrowed that down to a single possibility, then I use the LLM to suggest possible extensions on that, hoping that first word would give me good information value about what the second word might be. If I went my LLM strategy, rather than kind of like trying to teach the LLM how to play 20 questions and trying to teach it the logic flow of that, I constrained the logic flow and treated it really as a good at doing a number of very specific tasks, including enumerating lists, parsing, kind of splitting lists into different categories, into different locations, and ultimately use kind of a more mechanical approach to interact with the LLM, and constrained its output in some respects to get down to an effective output in an online mode while it was operating. In terms of the answer, this was actually fairly straightforward. I was basically using the LLM, but I found that a very key differentiator on the answering side was to actually modify the question slightly. So by finding the subject of the sentence, and I use the LLM to actually determine what's the subject of the sentence, and replacing that with the keyword, I found that the answer tended to give, qualitatively, I didn't run a lot of tests, qualitatively gave better output in terms of its yes/no fidelity. In terms of what I saw as key, success factors for this, I think alpha search obviously, was dominant at the end. Within that, there were still many competitors who had alpha strategies but didn't make it into the gold. And so I think there were a couple of key factors there in terms of how effective were they at searching the keyword search space, and how fast could they search it. It was also important to get some wins with other strategies, including kind of early wins with the LLM. And then I think also, particularly for this competition, kind of observing what was going on in the simulation was important, and staying on top of the comment board and on top of what was going on the leaderboard was important too. So let me go through this quickly. On the alpha search, I think everyone's kind of understands the logic here, but essentially being able to search a huge keyword search space in 20 questions if we're getting perfect binary splitting on all of this. And so I was using that approach. In my case, I used a slightly different approach than some of the competitors, and I'll get into that in a minute. Looking at the keyword find rate and search speed, I shared this online, but this is my analysis of how various teams did in terms of how quickly they were able to find the keyword in terms of reward, and then also the percentage of games that they actually found the keyword in time. And almost all of the competitors, above a certain line there, made it into the gold, with the exception of Benjamin Kovacs, who maybe had some bad luck there. But that's the best explanation I have for it. But I think it does explain why certain teams that implemented similar strategies fell a little bit short of where they needed to be in the top 20. Next, talking about early wins, and kind of getting out of the 600 range where a lot of competitors were trapped. And the trap being, and that there were a lot of competitors there that had used really old notebooks or forked public notebooks that weren't very successful at playing, or were hard coded to the public keyword list, et cetera, et cetera. And when paired up with them, it was virtually impossible, even with a strong agent, to win. So needing to break out of that 600 range, 600, 700 range, and actually have a few wins to be able to be paired with more effective agents was key. And so my solution to that was really to build the LLM strategy, which actually was how I started. I started with this, so I kind of backed into this, but this was my strategy in the game. However, I felt that this combined approach was the right way to do it, so I went all in. So both of my submissions used exactly the same code, so I didn't differentiate and have one that did alpha and one didn't. I said, let me have both go. And that actually, I think, was important, because my other agent would have placed in silver. So, a bit of the luck involved in this. And I analyzed and shared this on the forums about, just kind of trying to find some objective measurement of how well did different LLMs perform in the competition if we take all of the alpha games out of the mix. And I think that my agent would have done fairly well here. I mean, this is, I go into this in a little detail in my forum post, but there's still some biases and whatnot in this data. But I think that overall, my agent was quite effective, both as a guesser and as an answerer in the different roles here, but not the best. And clearly, Majimekun and C Number with their great solutions that they detailed their LLM solutions online. I think they really hit a great way of doing it with their offline pre-processing, as well as Agent Alpha, I should mention. On the competitive dynamics, I think here, a couple people mentioned that they kind of got caught off guard by Agent Alpha, and I think that it wasn't like it wasn't there, and people were talking about it, and even when you could see that, like, C Number, who was number one on the leaderboard, suddenly disappeared. And if you looked at what his agent was doing, he was clearly testing out alpha strategies. So, it was apparent to people who were kind of following the game that was the direction it was going to go. And I'm actually surprised that more people didn't pick up on that. So I think that was a key differentiator. And also, I think just following the forum posts. I mean, the one thing I love about the simulation competition is instead of waiting until the very end and all the results are released and seeing what everybody did, you can actually see in real time what are other competitors doing. I can look at And in this case, I looked at what C number was doing, winning at the leaderboard, and I saw how his questions were structured, and I realized he was doing something very different from me, which I experimented with. It didn't work, but it allowed for a little more iteration, and kind of kind of testing new ideas that you wouldn't get in a typical kind of one and done competition. How am I doing on time? Great. So I thought it'd be helpful just to show an illustrative game. This is an actual game that was played near the end of the competition against Pascal Pfeiffer, who was operating in a pure LLM answer and a fairly strong player. So this kind of illustrates how the program logic work. I start off with it, is agent alpha? He said no. I guess book. And on the right side, I'm kind of giving an illustration of what's my program logic thinking at that point. So it starts off saying, hey, I know this is going to be a thing. It's going to be a tangible object because virtually all the keywords are tangible. And so it's decided, online, I didn't pre-program this to test whether it's a living thing or an inanimate object. So I've asked it, I've asked the llama to basically try to separate things that are tangible objects into two groups that are not overlapping, and that's what it came up with: living thing and inanimate object. So, and it's proceeding accordingly. It's testing: is it a living thing? No. Is it an inanimate object? Great, I got a hit there. So I'm collecting these yeses, and I've now narrowed my categories taxonomy down to tangible objects that are inanimate, and I continue to follow that logic along. It's now saying man-made, natural. I've discovered it's a man-made object. And here, Llama suggested, oh, well, man-made objects can either be buildings or machines, which is perhaps not the best, categorization that it could have picked up with. Those are very specific. And in this case, the keyword was garage, and it answered yes, it's a building, so that's great. And I was a little bit lucky getting that. And then it's testing residential versus commercial establishments. And in this case, Pascal answered yes. So it said it was a residential structure, which I think most humans would not say a garage is a residential structure. I think it's better described as an attachment or even a commercial parking garage. But anyway, my program is kind of locked in, and now it's convinced that it's a building that's a residential structure. And so it's going to test 4 other categories: apartments, family home, retirement community. None of those work. And so because I received 4 consecutive no answers, I kind of realized that my program has hit a dead end, and it moves on to a completely different mode. And at this point, I asked the program, or asked the LLM, enumerate a list of different locations where a building that is a residential structure could be located. And so it's going to enumerate, a long list. I don't have the exact list, but this is illustrative of what it would look like in cities, towns, urban areas, rural areas. If it were a home object, it might enumerate, kitchen, bedroom, living room, dining room, and so forth. My theory is if I have information about the category as well as the location, it's going to narrow the search space very effectively in most cases. In this case, I get a hit on the first try. Yes, buildings with residential structures found in cities. Not a lot of information value there. Then I look at size. Is it small or large? Which also can narrow things quite a bit. So I've discovered very quickly that it's a small building. It's a residential structure. It exists in cities. So, while I've been using the LLM interactively here, I've also sort of constrained what types of questions that it's going to be asking, and I've gotten to a point where kind of that pre-programmed logic flow has exceeded, what I've pre-programmed in there. And so now it goes into what I call its kind of default mode, which is essentially enumerate 30 keywords that meet these criteria. So, 30 different small building residential structures in cities. And so it'll create a list internally in its memory of 30 different examples of what that could be. And then I ask it to come up with a question that would bisect that list, essentially, to try to create 2 overlapping lists of 15 keywords, which it doesn't do a perfect job at, but it tries, and it usually does, reasonably good questions. So here it asks, and this is all completely just LLM driven at this point. Is it typically found indoors? Not a great question. Is it commonly found in multiple or complex in a complex of multiple dwellings? Pretty good question. So it's starting to eliminate apartments versus, individual dwelling spaces. Is it a multi-unit dwelling? Does it provide permanent living space? Is it stationary? So it's not an RV and so forth. And still narrowing down, can you walk or drive on it? Kind of a weird question. I would actually say probably yes, I can drive on a garage. But here Pascal answered no. Does it have multiple floors? Yes or no? So I kind of narrowed it down to very small, single unit things. And the final guess that my LLM came up with was garage apartment, which was a failure, but quite close to the keyword of garage in all of this. So, I felt like this was a near miss, but a good illustration of kind of how the program, the LLM, walked through its logic flow. In terms of findings, I can't say I fully explored this, but my intuition was that the small LLMs are not good at learning games. And particularly what I saw of the early public notebooks was, they're trying to feed a lot of information about, how does the game 20 questions work? Here's an example of a question and answer flow, and try to copy this format. And I'm not convinced that a small LLM can do that. So I thought, well, let's focus on controlling the game flow, but using the LLM in very specific, very targeted ways to solve kind of piece problems within that larger game space. I found that the LLMs like to get natural language input. So if I give it a list of like yes/no questions, it's much less effective than if I can use itself to summarize first and kind of incrementally add information based on the question. So I'd take a yes/no question, turn it into a statement, append it to an existing summary of state. And so I kind of maintain this internal paragraph form summary of what I know so far. And it's actually, in a way, better at understanding that paragraph than it would be kind of trying to parse through, 15, 16 different yes/no questions every time. And, as part of that, I kind of, I'm fairly new at this, but I found it really interesting to see how I could wrap the LLM in function calls and ask it things I wouldn't normally think to do, like, oh, can I extract the subject of the sentence and wrap that as a function? Just say, here's my subject finding function, and that's all it does. But instead of trying to code all this logic or a bunch of regular expressions to do, language processing, kind of, putting the LLM in that position, and I found that quite effective. And then I think the last finding was really just, if you can't beat them, join them. And I think just like a lot of other simulations, where people come out with, wonderful reinforcement learning algorithms that are really sophisticated, sometimes, a short rule-based program can win. And I think here, that's no exception, where, simple solution that's maybe to some obvious, can be dominant here. And maybe if we had larger LLMs in the mix, then it would have been a different story. But that's kind of where we ended up. So thanks very much.